Welcome to my YouTube channel. Today we will discuss about the numericals of force topic, which is the first chapter of 10th ICSE, and that's A part is the moment of force. So initially we will discuss about the formulas, whatever is inside that topic. After that, just we will start the numericals. So in force topic, our topic is force, and in this topic, first term we have studied about moment of force. Especially just I am going to tell the formula. Moment of force is represented by torque, tau. It is product of force and perpendicular distance from axis of rotation. In general, we can write it tau is equals to R into F. Next term is couple. What is couple? Couple, we can draw the diagram for this. One force to this direction, another. So if two equal and opposite forces are acting at a point, at two different points, and suppose R is the distance, R or D sometimes also, whatever we can say, here AB is equals to R. So R is the distance, so couple is also represented by tau. It will be in this case R into F, where R is called moment arm and F is one of the force between two equal and opposite forces. And next thing, whatever we have to remember, that is the principle of moments. What is the principle of moments? Principle of moments states that clockwise moment, total clockwise moment is equals to total anticlockwise moment. Anticlockwise moment. So this is the basic part. And two more important points are there. One is that all distances always will be measured from fulcrum. All distances will be always measured from fulcrum, and weight of the body will exist at the center. So these two terms we have to keep in our mind for solving the numericals. So further we are going to start the numericals. So let us start. So first sum is here. The moment of force, as we can see, the moment of force 10 Newton about a fixed point O is 5 Newton meter. Calculate the distance of the point O from the line of action of force. So in this case, what informations are given? Just we can write. So what informations are given? We can write its solution as in that one given part. Force is of 10 Newton. So force is F. F is 10 Newton. And moment of force is torque. So tau is given. So we have to calculate distance of the point O from the line of action. So simply we can write force F is equals to 10 Newton and torque is equals to 5 Newton. So we know the formula, since tau is equals to R cross F or R into F. So R is to be find out. So R will be tau by F, and torque is given as 5 upon F is 10. So R will be 0.5 meter. So this is the answer. Now we will move to the second sum. Second sum, just will read the question. A nut is opened by wrench of length. Now this length will act as we are talking about, nut is opened by a wrench. So that's length will be moment arm, that is R, 10 centimeter. If the least force required is, force is given, R, moment arm is given. Find the moment of force. So moment of force is to be calculated. So what informations are given, just we will write first. So what informations are here given? What is given to us? Length means distance is kind of R, moment arm. It is 10 centimeter. We will convert in meter, so it will be 0.1 meter divided by 100, because 1 meter is 100 centimeter. So 1 centimeter will be 1 by 100. So 10 centimeter will be 10 by 100, which will be 0.1 meter. And force is given F as 5 Newton. So moment of force is to be calculate. So we know, since moment of force is equals to, we represent it by torque, it is R into F. Now R is 0.1 into F is 5. So answer will be 0.5, just 0.5. What will be unit? Unit of force is Newton, unit of distance is meter. So it will be Newton meter. It is the value of torque or moment of force. Now next question is question number 3. We can read the question first. A wheel of diameter 2 meter. Diameter is 2 meter. Okay, diameter means AB, whole length is 2 meter. Okay, so shown in the diagram with axle at O. Axle is here. Axle is at O. A force of 2 Newton. So force of 2 Newton is applied at point B in the direction shown. Calculate the moment of force about the center O and the point A. Again, I will repeat this part कि all distances are measured from fulcrum, and here it is given axle. Axle is at O, means all time we will measure the distances from point O. So what has been asked to us? Calculate the moment of force about the center O. About the center O. So all the informations we will write. Diameter means AB. AB is, what are the solutions? AB is as 2 meter. AB is as 2 meter. F is 2 Newton. I will write OA is equals to OB, that will be 1 meter each. Why? Because the diameter is of 2 meter. So OA, this will be 1 meter and this also will be 1 meter. That I have written. OA is equals to OB is equals to 1 meter. Now first part is to be calculated moment of force about the point O. So force is acting at this place and moment we have to calculate about O. So this distance will be 1 meter. So about O के लिए R will be 1 meter and force is 2 Newton. So we will write moment of force about center O. Moment of force about center O. Moment of force about center O. What will be that? Tau 1 I will write, because two things we have to calculate. It will be OB into F. Now OB is 1 meter into F is 2. So tau 1 will be 2 Newton meter. So this part is over. Its second part, the point A, about point A. So about point A, if we will say about point A, then this distance from the force, all distances we are measuring from force and about which point they have mentioned. So about point A, distance will be AB. So we'll write about point A. So we can write moment of force about point A. For this, it will be tau 2 is equals to AB into F, and AB is 2 meter into F is 2 Newton. So that will be 2 to the 4 Newton meter. It is tau 2. Fine. So this sum is over. Okay, one more thing, direction we have to mention. So as you can see, force is applied to this direction and about O it is asking. So definitely it will move like this. So this direction is clockwise, and about A also, force, direction of force is this one. So again direction will be clockwise. So in both the cases we can write direction will be clockwise. Okay, now we will move at next question, question number 4. So let us see fourth question. What is the fourth question? The diagram in figure 1.29 shows two forces. F1 is as 5 Newton, F1 is as 5 Newton and F2 is as 3 Newton. F2 is as 3 Newton acting at points A and B, acting at point A and B of a rod pivoted at center O. Rod is pivoted at center O, so that OA is 2 meter. Of course, it is given as 2 meter. OB as 4 meter. So again remember, number of times, 2 times already I have told, we have to keep in our mind 2 points. All the time distances will be measured from the fulcrum or pivoted point, and in this case this is the fulcrum or pivoted point. So all distances we will measure from here. And second, weight of the body will exist at the center. So these 2 points we have to apply for this sum, and we will do the sum. So first of all we will write all the given informations. So here F1 is 5 Newton, F2 is 3 Newton, and OA is as 2 meter, OB is as 4 meter. So first part is here. For first part, what is to be calculated? For first part, calculate the moment of force F1 about O. F1 about O. So what is the distance between O and F1? It is 2 meter. So moment is the product of force and distance. So we will write first part. For first part we can write moment of force, just we can write at different place because it will be mess completely. Okay. Yes. So first part, moment of force, moment of force F1 about O. It will be tau 1, I will say, because in 2-3 points they have asked, so notations should be different. So tau 1 will be as what I was said, it is force into perpendicular distance. So it will be F1 into OA. So tau 1 will be F1 into OA. So F1 is 5 Newton into OA. O is this distance as 2 meter. So 5 into 2, that is 5 to the 10. Unit will be Newton meter. So tau 1 will be 10 Newton meter. And direction also we have to mention. What will be direction? Now we have to think about it. As the force is acting to this direction, so as it is balanced on this one, so it want to come to this direction. So this direction is clockwise or anti-clockwise? It is anti-clockwise. So direction will be anti-clockwise. We can write over here, that will be anti-clockwise. Now second part, the moment of force F2 about O. F2 about O. F2 about O. F2 is here. About O we have to find out. So again distance we have to take 4 meter. And force we have to take 3 Newton. So in this case, what we will get? It will be tau 2 is equals to F2 into OB. So that part we will write, tau 2 is equals to F2 into OB. So tau 2 will be F2 into OB, but F2 is 3 Newton into OB is 4 meter. OB is 4 meter. OB is 4 meter. So 4 meter. So it will be 4 3s are 12 Newton meter. It will be tau 2. Next part, third part. What is third one? Total number of total moment of two forces about O. So about O, due to these two forces, one this will be to this direction, another will be to this direction. So what we have to do? We have to find out clockwise moment, anti-clockwise moment, and clockwise moment we take, clockwise moment is negative, anti-clockwise moment is taken as positive. Clockwise moment is taken as negative and anti-clockwise moment is taken as positive. So we can say according to principle of moments, according to principle of moments. What is the principle of moments? That sum of all the moments, that is net tau, will be tau 2 minus tau 1. Why minus? As I mentioned, again I will repeat that part. This is clockwise, anti-clockwise moment. This is anti-clockwise moment. Anti-clockwise moment, and this will give us clockwise moment. Clockwise moment is taken as negative and anti-clockwise moment is taken as positive. So probably I have tell opposite to that. Yeah, fine. So anyway, just we can write it both the ways. Tau 1 minus tau 2. So tau 1 is 10 minus 12. So 10 minus 12, that will be 2 Newton. So net torque will be 2 Newton. But we have to mention what will be direction of this resultant torque. So again, just we can see this torque is anticlockwise. Anticlockwise is taken as positive. So this is 10 plus 10 and this is minus 12. So 10, this is plus 10 and this is minus 12. So this moment will be more. So this moment is of what? It is about the clockwise moment. So resultant direction will be clockwise moment. That will be along clockwise. Clockwise moment. So direction, I think so direction part is also clear to everyone. Now we can see question number 5. Question number 5. Two forces each of magnitude 10 Newton. Two forces each of magnitude 10 Newton act vertically upwards and downwards, respectively at the two ends A and B of uniform rod of length 4 meter. Length of rod is 4 meter, which is pivoted at its midpoint O. It is pivoted at midpoint O as shown in the figure. Find the magnitude of resultant moment of force about point O. Resultant we have to find out. Resultant. So of course, what is to be found out as determine the magnitude of resultant moment of forces. So of course it is a couple. What is the identification of couple? If two equal and opposite forces are acting at two distinct points on the body, and that is said to be couple. So we can write simply resultant moment of force. We can write moment of force or couple. Since moment of force or couple is equals to one force into perpendicular distance between two forces. So according to that, just we will write tau is equals to one of the force, either this or this. So it is 10 Newton. So it will be 10 Newton and perpendicular distance between these two forces is AB. So we can write F into AB, and F is 10 Newton and AB is 4 meter. So of course it will be 40 Newton meter. This is torque. Now what is the resultant direction of this one? Just by this we can say this will apply the torque to this direction and this one to this. So this is the what? Clockwise. So it will be clockwise. So we can write it will be in clockwise direction. So this sum we have finished. Next, question number 6 we can see. Read the question carefully. In figure 1.31, this shows two forces each of magnitude 10 Newton acting at points A and B at a separation of 50 centimeter. This distance is 50 centimeter. Two forces, one is of this direction, another is about this direction. Calculate the resultant moment of two forces about the point A, B and O. A, B and O. O is the midpoint, I can say, of A and B. Of course it is given. O situated exactly at the middle of the two forces. So very simple. What is to be calculated as resultant moment of two forces. Resultant moment of two forces. So for first part we can write for first part. Again, what information is given, just we can write F1 is equals to F2, that is 10 Newton each. F1 is not given, I will take it as F1, say it is F2, say, and AB, distance between A and B. So AB, I will take AB is equals to 50 centimeter, which is 0.5 meter. So it is AB, and we can write OA, perpendicular distance, will be half of AB, will be equals to OB, which will be AB by 2, and AB is 0.5. So it will be OA is equals to OB is equals to 0.25 meter. Half of 0.5. First, we have to calculate the resultant moment of the two forces about point A. So just we can write about point A. So two forces will act on it. One, about point A, force is of course 10, but distance from A and A will be 0. So we can't write this force, we will take this force for the moment about point A. So we can write moment of force about A. Moment of force about A, that will be tau 1 is equals to F into AB, because another force is at this direction and one is this. Distance between these two forces is 0.5. So into AB we have to take distance between these two, AB. So F is 10 into AB is 0.5. So it will be tau 1 is equals to, or we can write tau A also, it will be 5 Newton meter. Next is second part. What is second part? Second is about B. So we can write same way. Now for B, this force will not calculate. We will see this force into this distance. So again it will be F into AB. So we can write moment of force about B, about point B, it will be tau B is equals to F into BA. I will take it as BA, but AB is same as the BA. So it will be 10 into 0.5. So it will be 5 Newton meter. It is tau B. Tau B. It is tau A. It is tau means torque. It is the Greek symbol. Now C or third we can say O situated exactly at the middle of the two forces. Now moment of force about point O. Now moment of force about point O. Moment of force about point O. About point O. What it will be? Tau O will be equals to, now think about it, what I am going to write, what we will write. About point O they are asking. Now all distances we will measure from O. So O to F, this distance, OA, we will use this point. And for B, this distance, OB is again this. So force will be of course 10 and 10. So what it will be? It will be F into OA, F into OA plus one of the moment. Another moment is F into OB. Again I am telling how I have written this. Moment about point O we needed. This is the axis of rotation now, and this is the distance between force and perpendicular distance. This is the force and this is the perpendicular distance. So OB and OA. So one force is this and into OA, another force into OB. That I have written. Now forces are same, so we can take out common. So it will be, F is common, you will get OA plus OB. But OA plus OB is AB. So F into AB. So F is 10 into AB is again 0.5. So it will be 5 Newton meter. It is torque about point O, tau. Now we'll see next question, question number 7. Question number 7, we can read the question. A steering wheel of diameter 0.5 meter, again diameter is 0.5, is rotated anti-clockwise by applying two forces each of magnitude 5 Newton. Draw the diagram to show the application of forces and calculate the moment of force applied. Fine. So let us draw the diagram for it. This is the steering wheel. This is the steering wheel. Diameter is 0.5 meter. Diameter we will draw 0.5 meter. So we can take any two different points. One is this, another is this. So we will join them. This A and B. So this is the diameter. It is point A, it is point B. Diameter is 0.5 meter. So AB is 0.5 meter. Is rotated anti-clockwise like this. It is rotated anti-clockwise like this. Fine, anti-clockwise. By applying two forces each of magnitude 5 Newton. Forces, two forces are there. One force is to this direction, one force is to this direction, another force is to this direction. It should be proper. Okay, we will do it. Done. Two forces each of magnitude 5 Newton. So this force is 5 Newton and this force is also 5 Newton. So we draw the diagram of the steering wheel. Again it is, and calculate the moment of the force applied. Moment of force applied. So everything we have, what we have, just we can write. What we have? Forces F1 is equals to F2 is equals to 5 Newton. Why I am writing like this? although F1 and F2 is not there, but we are writing because they are they are equal in magnitude but in opposite direction. So F1 and F2 is as 5 Newton, and perpendicular distance between these two, that will say moment arm AB is equals to 0.5 meter. So we know since moment of force is equals to F into AB, perpendicular distance between two forces. So moment of force tau is equals to F is 5 Newton into AB is 0.5. So it will be 2.5 Newton meter. I think so it's really easy for you people. Now next question, question number 8. Question number 8, we can see question number 8. A uniform meter rule, a scale whose length is 1 meter. 1 meter means 100 centimeter. 100 centimeter it is. So it is a meter rule. Is pivoted at its midpoint. So we have to draw the diagram for it. So this is the meter rule. Length is 100 centimeter. Let us draw it downside. This is meter rule whose length is 100 centimeter. It is pivoted at the center, midpoint. Midpoint is kind of center, and it is what? Meter rule. Length is 100 centimeter. Weight of 50 gram force is suspended at its one end of it. Where should a weight of 100 gram force will be suspended to keep the rule horizontal? So again, to keep it horizontal, suppose we are applying the weight to this side 50 gram, and 100 gram definitely we have to apply it to this side, but position will be different. That is to be calculated. Again I will tell you, two very important points are there that you have to remember. Every time all distances will be measured from the pivoted point or fulcrum, both the words, and pivoted point is over here. This is the pivoted point, and weight of the body always will exist at the center, that is midpoint. So keep these 2 points in mind. Let us see. So according to given condition, weight of 50 gram is suspended to at one end of it. I will take this end A. Here a force of 50 gram is given, F1 I will say, 50 gram force at one end of it. Where should a weight of 100 gram force? That distance we don't know. Suppose we want to attach that weight definitely at this position. At this position it is 100 gram. So F2 we will say it as 100 gram force. 100 gram force be suspended to keep the rule horizontal. Now this is end B, and of course this point I will take as center O, that center is O. Now we can write all the informations about this part. So definitely OA will be 50 centimeter because it is a meter rule, 100 centimeter. AB is 100 centimeter. AB is 100 centimeter. So OA is equals to OB will be 50 centimeter each. So this is 50 centimeter. And this distance we don't know. This distance is suppose x from center O. X is the distance from center O at which we are going to attach the load of 100 gram force. So we will have two moments, one is this, another is this. This will provide which? Anti-clockwise moment, and this will provide clockwise moment. So again, according to principle of moments, clockwise moment is equals to anti-clockwise moment. So now we will write according to principle of moments, according to principle of moments, according to principle of moments, we will write according to principle of moments, clockwise moment and anti-clockwise moment. So I will write F1 into OA is equals to F2 into X. So we can write F1 is as 50 into 50 is equals to F2 is 100 into X. So 50 2s are 100. So you will get 2x is equals to 50. So X will be 25 centimeter from point O, from O to another side, mean to say 50 centimeter from O to 50 centimeter at this, sorry 25 centimeter, it's not 50, it's 25 centimeter. So we get the answer. Next is question number 9. Question number 9, what it is? A uniform meter rule balances horizontally on a knife edge placed at 58 centimeter mark. Again, it is a meter rule, means 100 centimeter, and it is balanced means it is pivoted. Balances horizontally means it is pivoted at 50 centimeter mark. So just again we have to draw the diagram for it. This is any meter rule, and of course it is pivoted at 58 centimeter mark. This is 58 centimeter mark, 58 centimeter mark, horizontally on a knife edge placed at 58 centimeter. When a weight of 20 gram force is suspended from one end, any end we can take. So definitely from which end we have to, of course it is balanced at 58, then definitely from this end we have to attach the weight of 20 gram force. One end, it has been mentioned 50 centimeter mark, 58 centimeter mark, when a weight of 20 gram force is suspended from one end. 20 gram force is suspended from one end. So draw the diagram of the arrangement. What is the weight of the rule? The weight of the rule, weight of the body will exist always at the center, and of course it is meter rule. It is a meter rule. Whole length is 100, where its weight will be at 50 centimeter mark. So weight will be downward. It will be at 50 centimeter mark. Right? So what we have to find out? Draw the diagram of the arrangement. This is the diagram of the arrangement. What is the weight of the rule? What is the weight of the rule? Weight means this is to be found out. So again this will provide the anti-clockwise moment and this will provide the clockwise moment. Again, according to principle of moments, anti-clockwise moment is equals to clockwise moment. And again that point I will repeat every time, distances will be measured from the fulcrum or balancing point. Balancing point is here. So we can write this distance will be 8 centimeter, and of course this will be 100 minus 58, that will be 42 centimeter. So we can give the name A, B, this is O, this is C. So all the informations we can write OC will be, again I will change the color and I will write it different way. See, this is C, this is O, of course AB. So OC is 58 minus 50, so it will be 8 centimeter. And next is CB. CB will be 100 minus 58, that is 42 centimeter. So again I will write the basic principle, clockwise moment is equals to anti-clockwise moment. So we can write according to principle of moments, according to principle of moments, according to principle of moments, clockwise moment is equals to anti-clockwise moment. So W into distance is OC is equals to another force is 20 gram force into that distance is CB. So W into OC is 8 is equals to 20 into CB is 42. 8 sevens are, sorry, we have to calculate it. So 4 2s are 8 and 4 5s are 20. So 2 21, 21 5s are 105 gram force. This is the final answer. Next is question number 10. Question number 10. Read the question carefully. The diagram below shows a uniform bar supported at the middle point O. Again, middle point O means that is the fulcrum or balancing point. To the left at, a weight of 40 gram force, is placed at a distance of 40 centimeter. 40 centimeter, this is the 40 centimeter. So we can draw it like this. It is 40 gram force at the mark of 40 centimeter. It is 40 gram force because its direction will be downward. Is placed at a distance, okay, to the left of the point O. How can you balance the bar with the weight of 80 gram force? 80 gram force, that is, we don't know where we have to keep. So suppose we are going to keep over here at any point, 80 gram force, 80 gram force. Now this distance is suppose x, it is x. So if it is x, then again we have to apply the principle of moments, and we can write this distance will be, of course it is 0 to 40, so 40 centimeter. So according to principle of moments, according to principle of moments, clockwise moment is equals to anti-clockwise moment. So 40 into 40, this force into distance, 40 into 40 will be equals to x, distance is x, into 80. Now 42s are 80. Now 2x is equals to 40. So x will be 20 centimeter. So at which mark it is asking? Of course 20. because from 0 we are calculating, right? So at the mark of 20 centimeter. This is the final answer. Now question number 11. Question number 11 we can see. Question number 11, just we will read the question. So the uniform meter rule placed on a fulcrum at its midpoint O. Fulcrum is, again it is telling midpoint O, and having weight of 40 gram force at 10 centimeter mark. 40 gram weight at 10 centimeter mark. So this distance will be 50 minus 10, that is 40 centimeter. 40 centimeter, and weight of 20 gram force is at 90 centimeter mark. Is the meter rule in equilibrium? That we have to check. For equilibrium we can write, for equilibrium what should happen? 40 into distance, this distance, once we will write this distance is 10, 50 minus 10, that is 40. And what is this distance? This distance is 90 minus 50, that is 40 again. So we will write 40 into 40 is equals to 40 into 20. So this is not is equals to. Mean to say, this is the clockwise moment, 40 into 40 gram force into 40. Well, this force will be downward. And here this distance is 40 into weight is 20, 40 into 20. So they are not equal. So it is not in equilibrium. So we can write, therefore it is not in equilibrium. It is not in equilibrium. Now second part, is the meter rule in equilibrium? So no. Second part, how can the meter rule be brought in equilibrium by using an additional weight of 40 gram force? So we don't know. Let us see. Just we have to choose ki wo weight, that weight we will keep to which side. Now this is 1600, means this will be 1600. We are going to mention its weight also to this direction and this. So this is anti-clockwise moment. Anti-clockwise moment is 1600 and clockwise moment is equals to 40 into 20. So it is 800. So just we will write in wordings. So clockwise moment, anti-clockwise moment is equals to 40 into 40, that is 1600 Newton meter. Okay, it is 1600 Newton meter. And now clockwise moment that will be 40 into 20, that is 800 Newton meter. So resultant, or we can say difference in moments, that will be 1600 minus 800, that is 800 Newton meter. Again, why I am taking that difference, just I will explain. It is anti-clockwise moment. It is 1600 and this is clockwise moment, of course. So if we are going to add next 800 Newton meter to this side, so it will be balanced. That will be in equilibrium and with the 40 gram force. So distance, how can the rule be brought? So new distance will be, we can write new distance that will be, suppose that is x, So for new distance I will write, for new distance we will write 800 is equals to weight, additional weight is 40 gram. So 40 into x, we can write 40 into x. So x will be 20 centimeter from the fulcrum to the right side, mean to say here at the position of, it is balanced at 50, so at the 70 centimeter we have to add the weight of 40 gram force. This distance is of course 20. So this part is clear, I think so. Next, question number 12. We can see question number 12. When a boy weighing 20 gram force sits at one end of a 4 meter long seesaw, it gets depressed at its end. How can it be brought to the horizontal position by a man weighing of 40 kgf? Now very simple, 4 meter long seesaw. Just we will draw the diagram. It is a seesaw, 20 kgf, boy is of weight 20 kgf. Seesaw is of course balanced at, that's pivoted point will be at 2 meter. Overall length is 4 meter. This point I will take as O. This is A. This is B. Overall AB is as AB according to this diagram 4 meter, and one of the force is F1 is this, and another person of weight of 40 kgf. How can it be brought? Okay, this distance we don't know. Okay, where he will sit with the 40 gram force. So just we can see clockwise moment is equals to anti-clockwise moment, but we don't know this distance, so we have to assume it as x. Of course this distance will be 2 meter. So clockwise moment is equals to anti-clockwise moment. We can write, therefore according to principle of moments, clockwise moment must be equals to anti-clockwise moment. So F1 is 20 into 2 is equals to 40 into x. So 40 is equals to 40x, so x is equals to 1 meter. X will be 1 meter from pivoted point. That is the answer. Where the person should sit, that person should sit at distance of 1 meter from the pivoted point, pivoted or balancing point.